the 400 on both sides. So we'll add it here. So this gives us basically nothing. And we end up with 30x minus, okay, so we're doing a negative 170 minus or plus 400. Let's see, 400. This 230. And this is plus 230 equals 7x. Now, we still don't have our x's all on one side, so we do need to do that. Now, we can either move the 230 out, but I think we need to do like a swap. So, excuse me. So we need to do like a, let's take the 30x. Well, I like to have the x's on the left-hand side. I don't know why. I think it may be the way I was taught, but let's move the x over this way, and then we'll move the 230 over this way. So this is positive in front of it. Is a plus sign. We'll do negative 7x. That essentially turns into nothing, but we need to do it on both sides. So that turns into what, 20 something? What do you think? It's 23x, excuse me, and equals negative 230. Because I took the 230, subtracted it, and then moved it over here, did a negative 230. That's what gave me this. Okay, so let's kill the 23x. This is multiplication. Opposite of multiplication is division. Right there. So x equals negative 10. And that's the answer. All right. So now we're going to move on to some different types of things. We have types of linear equations in one variable. We have conditional, where we have an actual value or values. We have contradiction, which there's no solution at all. And we have identity, which has all real numbers. So any number you put in there will make the statement true. So conditional, only a certain number will work for that equation. Contradiction, there's no solution. Identity, any number you put in for x will solve the equation. And those properties are in your book, page 60. So for each equation we're going to do here, we're going to solve and then label the equation as a conditional, identity, or contradiction. So the first one, 3x plus 2, that is an x, believe it or not, equals 6x plus 4. Now I can already see if we take this 2 and distribute it, we're going to end up with 6x plus 4. But we must do it and then follow our steps. So 2 times 3x and then 2 times 2. This is 6x plus 4 equals 6x plus 4. Now, when you have something like this, where the exact same thing equals the exact same thing, this is an identity. Identity means all real numbers will work. So this is an identity. This means any number we plug into x is going to work. We could put 0, We could put 3 billion. It don't matter. It's going to work. It's all going to solve out correctly. Okay. So let's look at the next example. 3b plus 2 equals b plus 4. Hmm. So what do we do with this one? Simplify both sides is our first step, but it looks like it's so I cannot write a 3 on this program. 3. Okay. Simplify both sides, but that's already been done. Um, and the two sides are, oh, sorry. I mean, okay, we can do some maneuvering around. We know how to solve this, right? We just want to get B on one side and the number on the other side. Seems like it should solve this. And since these are not exactly the same, there's not identity. So let's do that. To move the 2, we just subtract the 2 out. Okay, and that leaves nothing here. And of course, this will leave a 2 here. To move the B, let's subtract the B out because it's positive right here. Positive, positive. Okay. Subtract 1B. And so if we subtract 1B, we're left with 2B equals 2. Now this is multiplication. We're going to divide to get rid of it. And this is B equals 2 over 2, which is just 1. And that's the answer. Now, since we could find an answer, a number that works here, not all numbers, we found a solution, so it is conditional. Okay, conditional. All right, let's go and look at some more of these. This one, oh, well, maybe I should. There we go. This example is 1/2 of x plus 11 equals 5/2. Now, the book wants you to simplify the equation, multiply both sides by 2 to clear the fraction, which it makes sense. And, I'm okay with that. You can work with fractions. It's not impossible. It's maybe harder for some people to think about, but you can do it. Um, don't think you can't. But yeah, we can clear the fraction with multiplying by 2. So let's do that. Both sides by 2, though. So what that means is you need to you need to write your 2 and then understand that you're doing this right here. You're actually distributing. Oh, that's supposed to be one and little. Good grief. There we go. Okay. So don't forget this part if that's what you want to do to clear the fraction. So, so to clear this fraction, we would do 2 times 1/2 x, which is just x, and 2 times 11, which is 22. Now, if you don't know why that's just x, I mean, it's basically 2 over 1 times 1 over 2, which equals 2 over 2, which is actually just 1. That's why that's just x. All right, so this guy, I mean, it's just going to be 5, but we'll do the math. So the 2 over 1, this guy here, and times 5 over 2. So let's do the math. We can do 10 over 2, which is 5 over 1, which is just 5. Or you could have crossed out the 2's and realized that, hey, it's just 5. So okay. So we're writing down our 5. Now let's get x by itself. This is going to be negative 22 here. So x equals negative 17. That is a solution. It's a negative solution, but it is a solution. So anytime we find a solution, one solution, not infinite number of solutions, but one solution, it is conditional. If I can write this with this, okay, good. Okay. Now, let's start with a different one. So this is a, oh my goodness, that is not an A. Okay. A plus 3. Okay, you know what? I'm going to use x plus 3. I cannot write an A equals x minus 2. Now, these two aren't the same, and there's no simplification that we can do. So we could try to solve it. Um, One way we could try to solve it is just let's move the 2 over, add on this side, turns into nothing. Add on this side, same thing on both sides. So this would be x plus 5 equals x. Let's move, let's go ahead and just move this x over here since one step. So this is a plus. We're going to negative the x over. This is plus 1, minus 1. That gets rid of that. And then this is, excuse me, negative. This is a 1, remember, 1 in front of it, x. So, wait, this is a positive 1 right here, isn't it? What happens when you do a positive 1 and a negative 1? It goes away. So the answer is 5 equals 0. This is not equal. It's obviously 5 does not equal to 0. It's not a solution because there's no x provided into it. So it is a contradiction. There's no solution. It's a contradiction of terms. All right. Okay. So let's go over another one real quick. They'll be throwing these at you too. These are you shouldn't have any problem with these. Okay, equals 2w plus 24. So if we take and we do the distribution of each number in front, we're left with 4w plus 4 times 12, which is 48, equals 2 times 2, which is 4w, plus 2 times 24, which is 48. And this are equal. So this is an identity. Meaning all identity. Yeah. Okay. Meaning all real numbers will work. All right. Let's move on to absolute value equations. Now, should we move on to that? I think we should. It won't take long. Yeah. Okay. Absolute. But do you know what absolute value is? And I can't get feedback from you, but I think you have seen it before, especially last year. Yeah, you definitely saw it before. Okay, so if I wrote something as absolute value, okay, well, undo it. there we go. X with two bars next to it. That is X, the absolute value of X, which you could write as equals X, where if X, oh, if X is greater than or equal to 0, or negative X, where X is less than 0. So you can write it as X or negative X. Remember this part of it big time, because this is how you're going to solve equations, just like that. All right. Now, absolute value equations. They can be fun. They can be long-winded, but mostly fun. All right. We're going to write an equation. Absolute value of X plus 7 equals 13. Now, because that is an absolute value, we have to rewrite this as X plus 7. You know what? I don't know why I write it so far down. We have to rewrite this. You know what? Let's do this. I'm just going to change my whole perspective. X plus 7 equals 13. And we're going to rewrite this as negative, negative, negative. X plus 7 equal to 13. And positive X plus 7 equal to 13. And the fun part is we get to solve both of these. So first we distribute our negative. It's really just a -1. So we're distributing that -1 into here. So it's negative X minus 7 equals 13. And then we just solve. So push this over to this side. All right. So this would be negative X equals 20. That's 7 plus 13. And then we still have this negative here. We're just, it's actually -1. So it's multiplication. We divide out by -1, which makes this X equals -20. This one is pretty straightforward. There's no remaining negatives to work with. So, oh, excuse me. So we just say X is equal to what? 6? Yeah, 6. And these are the two answers. And you could check them. You could plug them back into X, both -20 and 6, and they would both produce 13. In your homework, you may be required to check those. It's fine to check them. I think checking them is really good. I think it's very helpful. That way you know you've done it right if it comes out to check properly. All right, let's work on the next one. Feel like it. Excuse me. All right, so here we go. 12 absolute value of A minus 3 equals 36. Now, because we have this 12 in front of this absolute value, we can't just start splitting this out. Got to get rid of that 12. And this is multiplied. This is almost like having parentheses here. These bars are almost like parentheses. So, but we don't distribute it inside. We cannot distribute this inside here. So I guess it's kind of like parentheses, but it's not. Okay. Having said that, this is multiplication. The opposite of multiplication is division. And that's what we're going to do. So we're left with absolute value of a minus 3 equals, I'm sorry, I lost my place. But anyway, that's a 3. So now we can branch this off. So we have a negative a minus 3 equals 3, and a minus 3 equals 3. Let's distribute our negative. Negative a plus 3 equals 3. And let's just copy this or get this 3 over. So negative a, this is minus 3. And negative a equals 0. Oh, now did I do something wrong, or is that right? Well, it seems to me that I don't have to say negative a equals 0. I could just move that negative, excuse me, um, over to this negative 1, right? So I divide by negative 1. 0 divided by negative 1 is nothing. So this is just a equals 0. That's for the negative part. For the positive part, let's do this. Add both 3 to both sides. So this is a equals to 6. That's your 2 solutions right there. Okay. Excuse me. All right. Now, let's try a different one. A little more practice for you. This is absolute value of 2x minus 3 equal to 4x. So simplify both sides. That's been done. Absolute value. We need to isolate the absolute value. It's isolated. So we just go with our little tree math and go for it. So negative 2x minus 3 equals 4x. And then just 2x minus 3. I didn't have to write parentheses there, but I'm not sure why I did. I guess it was just for fun and kicks and ha-has. There. All right, so let's start with a negative one. This rewrites as negative 2x plus 3 equals 4x. And let's get this x. Let's do this one. Plus 2x. And then this is plus 2x. So this will be 3 equal to 6x. And we divide out that 6. That is x equals to 3/6, which is just a half. Now, let's do this side. And this side is, should be a little easier, perhaps. But this is actually negative 2x we're taking out. So 4x minus 2x, this will be negative 3 equals to 2x. Knock out the 2, and you get x equals negative 3 over 2. And that's the answer for that. Okay, so that is how you do absolute value. If you have any questions, let me know. Our last little piece of information we have is literal equations. There are independent variables and dependent variables on here. for these. Oh, um, literal equations. Let's see. Hmm. Excuse me. They solve out by the same way, but there's two variables in here. So and that's the two variables I was telling you about is the independent and dependent variables. But your book will tell you which variable to solve for. So say for this example, ax minus c equals 5x. And it says solve for x. We also have variable a and variable c, but we want to solve this for x. So the way you do that is just like you would do any other um, any other way to solve. We need to get x on one side. So to do that, we would just subtract this 5x out and put it on this side. So let me add a subtraction 5x over here. Oops. Now, because this is an A, you can't combine it with this one because this is A. But let's go ahead and add this C out. So what we get is AX minus 5x equals C. And goodness, that's a 5. Okay. So now we can pull out like variables. And the one like variable is the X here. So for this and this, we could write it as X, A minus 5 equals C. And then to solve for X, that's multiplication. To undo it, we do division, like A minus 5 on both sides. So all the same principles apply. You're just moving variables around. It's C over A minus 5. There, that's the answer. That's how you solve for X on those. And you'll have some of those, but you won't have a lot of those. All right, homework. Yay, it's time for homework. Finally. I want you to do three. hmm, Yeah, so you need to do literals also. Oh, yeah, okay. Actually, I want you to do 3 through 36 blue. And if you have any problems with the word problems, I want you to bring them to me. Or any problems, just bring them to me and I'll help you. So 3 through 36 blue. And good luck.